Hello students, welcome to Spectra Education Academy. In this video, I am going to explain answers for a few more questions which are given in previous NEET exams from the same chapter, Work Energy and Power. In the previous video, we covered answers up to question number 10. Now let us move to question number 11. A force F is equal to 20 plus 10y acts on a particle in y direction, where F is in Newton and y is in meters. Work done by this force to move the particle from y is equal to 0 to y is equal to 1. I think you remember that whenever force is variable over a given distance, so we go with integration questions. Since they mentioned y, better to write f dy with integration limits 0 to 1 meter. So f is given as 20 plus 10y dy. Integration limits are from 0 to 1. So 20 with dy 0 to 1 plus 10 with y dy 0 to 1. So integration of dy is just y. 0 to 1 upper and lower integrals. Integration of y is y square by 2 with the limit 0 and 1. So therefore, so the next process to substitute upper integral in place of 1 in place of y and the lower integral also. So nothing you'll get here. Plus 10 into, so you take 2 outside. Substitution of upper integral. So y square, y in place of y 1 minus 0. So therefore, this is 5 times. The answer is 20 plus 5, 25 joule. So third option is correct. So this is given in 2019. Now moving to the next question. So part of the answer is covered in the previous video. Okay. The mass M is attached to a thin wire which is varied in vertical circle. The wire is most likely to break when? So at what point? So during the vertical circular motion, at which point wire breaks? So this is what the question here. So this is once again vertical circle from the center. When particle is here, so let us first find out the tension at a given point P. So when string makes an angle theta, then tension acts towards the center. Then next mg to act vertically downwards. So there will be mg cos theta balances the tension. So now the net force P minus mg cos theta is equal to centripetal force. So R is the radius and L is equal to length of the string. So now radius of the circle is equal to length of the string. So now when it is at point A, the string makes an angle 0 with the imaginary vertical. So therefore, if theta is 0, then P minus mg cos 0 is 1 only. This is mv. So when it is a, so you might know the velocity it possesses to complete the vertical circle. When it is at a is 5 gr, because we got in the previous videos VA is equal to 5 gr. So now particularly 5 gl, because R is equal to length of the string. So this is 5 gl divided by L and L get cancelled. So mg will come this side. So T is maximum at point A. So that is lowermost point. So this is going to be 6 mm. So last option is correct. This is given. This is also given in 2019. Moving to the next question. Body A of mass 4m moving with the speed u collides with another body B of mass 2m which is at rest. So u2 0. The collision is head-on and elastic in nature. After collision, the fraction of energy lost by the colliding body A is, so kinetic energy lost means it is transferred to the second body. So first let us write kinetic energy transferred to the second body is the mass of second body is m2 with v2 square. So get back the expression of v2, that is 2m1 u1 divided by m1 plus m2 plus m2 minus m1 with u2, then m1 plus m2 Since U2 0, second body is at rest, so this quantity vanishes. So you'll be left with V2 is equal to 2m1 U1 divided by m1 plus m2. So let us substitute this equation 2 in equation 1. So how the kinetic energy transferred will be? So TR is equal to half m2. So V2 is this, but there is V2 square. It will be 4m1 square U1 square divided by m1 plus m2 whole square. This can also be written as half m1 u1 square. So this is the initial kinetic energy before collision of the first body. Then you will be left with here 4m1 m2. There is m1 here with m2 divided by m1 plus m2 whole square. Now this is kinetic energy transfer. So the question is fraction of kinetic energy transferred. So transferred by the first body means, so it is the loss of kinetic energy of the first body means kinetic energy transferred to the second body. So this is initial kinetic energy. This is initial kinetic energy of the first body. So 4m1. What is m1? 4m into m2 2m divided by m1 is 4m plus m2 is 2m. This is whole square. So this is going to be 1632m square divided by this is 6m. So this is 36m square. M square get cancelled. 4 8s and 4 9s. So therefore 8 by 9. So it can be fraction of the kinetic energy lost by the first body or kinetic energy transferred to the second body. The meaning is same. Moving to the next question. That is question number 11 given in 2019. 14, sorry. Yeah. When a block of mass m is suspended, so this is block is suspended by a wire of length m, by a wire of length L, capital L. So the length of the wire becomes L plus L. So due to the weight of capital M, so there might be elongation in the wire. So the elastic potential energy stored in the extended wire is. So first let us say already there is potential energy stored. This you call it as initial potential energy. So in general potential energy, the based on the point of center of gravity. So therefore this is going to be mg L by 2. Center of gravity for the extended body acts at half of its length. So this is initial potential energy. Now elastic potential energy is half kx square. So in chapter work energy, so there is a formula, stretching force. Let us say force with which spring is stretched is directly proportional to x in opposite direction minus x. So on removal you will get x kx. So now k can be replaced with f by x. So therefore half into, so this can be f. So therefore by x into x square. So therefore this and this get cancelled. F is once again mg. This x is as per the question capital L plus small l. Now we are talking about potential energy difference only. This you call it as final potential energy. So then potential energy difference is equal to PE2 minus PE1. Then PE2 is half mg of L plus L minus mgl by 2. So this is expanding of mg with capital L plus mg by 2 minus mgl by 2. So these two get cancelled. So this is the answer. So third option is correct. Moving to the next question. The energy required to break one bond in DNA is 10 to the power of minus 20 joule. So we need to find out the value in electron volts. This is given 2020. So energy required is given in joules. They are asking us to express this in electron volts. So remember 1 electron volt is equal to 1.6 into 10 to the power of minus 90. This is charge of the electron. minus 19 joule. So therefore, from this 1 joule can be written as 1 electron volt divided by 1.6 into 10 to the power of minus 19. So therefore, we need to substitute this is make it as minus 20 into 1 joule. So therefore, 10 to the power of minus 20 into 1 joule is 1 electron volt divided by 1.6 into 10 to the power of minus 19. So this and this get cancelled. There will be minus 1 here. So that we can make 1 electron volt by, when you take this minus 1 down, so it will be 16. So somehow get this as 100 into 10 to the power of minus 2 into electron volt divided by 16. This is 16/6 roughly. So therefore 6 by 100 electron volt. So the answer is 0.06 electron volts. So fourth option is correct. Moving to the next question. This is question number 16. Water falls from a height 60 meters. So this is the height 60 meters. Rate at a rate of 15 kg per second to operate a turbine. The losses due to frictional force is 10% of the input energy. How much power is generated by the turbine? So first let us say what is the energy, potential energy loss that reappears in the form of kinetic energy. First, how much is the potential energy when water falls from a height? Potential energy, potential energy by mass. First we write down potential energy is mgh. Since they did not mention anything directly m, so continue to have m into g into h. H is 60 meters. So this will be equal to g10 means 600 m. So this is the potential energy. So in this potential energy, 10% is lost due to frictional force, frictional energy. This is input energy 600, out of which 10% means 600 m into 10%, 10 by 100. So it will be 0, 0. This is 1 0 cancel 60 m. So this we need to subtract from 600. So therefore 600 m minus 60 m. So this is going to be 540 m. So m is mass of the body. Now, so question is to find out power. So power is equal to energy by time. So this is energy remaining, you call it as, by time. So energy remaining is 540 m divided by time. So m by t they mentioned as 15 kg per second. So P is equal to 540, 15 kg per second. M by M is mass, kg measured in kg, T seconds. So 540 into 15. So let us multiply 15. 15 4s are 60. 70 by 81. So already there is one more 0. 8100 watt. Otherwise 8.1 into 10 to the power of 3 watts. So this can also be written as kilowatt. Yeah, so second option is correct. Moving to the next question. This is given in 21 NEET. A particle released from height S from the surface of the earth. At a certain height, its kinetic energy is 3 times. So let us say this is the path along which body travels after it is released. U is equal to 0. After covering a distance x. So this is the entire distance S. This is ground. Then here it will be the remaining distance S minus x. So after x, the kinetic energy is 3 times of potential energy. So let us write kinetic energy half mv square. Let us say this is B point B, this is E, this is C. So mvb square is mvb square is equal to 3 times of potential energy. It is mg. In general, potential energy measurement is always from the ground. So the height is S minus x, remaining height. M and M get cancelled. So making use of Vb square minus U square is equal to 2As. So since U0, Vb square is equal to 2 into minus G into X is the distance, since it is downwards negative. So therefore VB square is equal to 2gx. So let us substitute. This is equation 1, this is equation 2. Equation 1, this is 2. Substituting 2 in 1. 2 in 1. So therefore 2gx is equal to 3g of s minus x. Then g and g get cancelled. So this is going to be, there is one more half is there here. This 2 and 2 get cancelled. So now 3s minus 3x is equal to x. So this is the 4x is equal to 3s. Now x is equal to 3s by 4. So but the question is not to find out x. So you have to find out the position from the ground. So that is x dash is equal to s minus x. So s minus 3s by 4. So therefore 4s minus 3s, it is s by 4. So this is the position from the ground. Now also we need to find out speed of the particle at a point B in the middle. So VB square with 2gx. So x is going to be 3s by 4. Then this and this get cancelled. So now VB is equal to under root 3gs by 2. So the last option is correct. Under root 3gs by 2. Next, moving to the next question. A shell of mass m. So this is shell of mass m. It is at rest initially. Explodes into 3 fragments having masses in the ratio. So let us say m1 is 2m. m2 is also 2m. m3 is m. If the fragments having equal mass flies off, so therefore 2m will go like this. Another 2m will come like this because these two are at right angles. So we need to find out velocity of the third fragment. So making use of law of conservation of linear momentum. So initially 0. So it's a big body, its initial velocity. Then after that, they split into 3 fragments, m1 v1, m2 v2. But since these two pieces are moving perpendicular, so making use of parallelogram straight away. So therefore, momentum P2, momentum P1. So applying parallelogram, and theta quantity does not exist because theta is 90. So in the parallelogram, cos theta term is involved. So when theta is 90, that does not exist with m3 v3. So therefore, m1 is 2m, v1 is v whole square, m2 is also 2m, v2 is also v whole square. So this is anyhow 0 left side. This is under root plus m3 v3. m3 is m only, v3. So therefore, this is 4m m square v square plus 4m square v square. M square v square you take out common, multiplied with 8. So this is all under root is equal to minus mv3. So therefore, this is 2 root 2 mv is equal to minus mv3. So this and this get cancelled. So the answer is first option. Now moving to the next question. Question number 19. An electric lift with a maximum load of 2000 kg. So this is the mass of both lifter and passengers moving up with a constant speed. So 1.5 meter per second. The frictional force opposing the motion is 3000 newtons. The minimum power delivered by the motor to the lift in watts. So power in general is included with the work rate at which work is done. This work can be written as a force into displacement by t. So displacement by time is velocity. This is another example of dot product between two vectors. So you treat this as net force. While going upwards, net force is, so weight anyhow to act downwards. So when body is moving up, frictional force opposes the motion. So this is M is 2000, G is 10 plus opposing force is 3000 newtons. Altogether, this is 23,000 newtons. This is net force. Then net force is multiplied with velocity to get power. 23,000 into 1.5. So this is going to be 23 into 1.5. Otherwise, you cancel 1 0 and make it 15. So this is 15 3 the 45. 15 to the 30, 34. So 34, 5, 34500. So your measuring power means is represented in watt. Students, in my next session, I'll continue explanation for the questions given in previous NEET exam. Chapter name is System of Particles and Rotational Motion. Thank you very much for watching my video, but don't forget to share and subscribe with your friends and relatives.